Hey guys, today's 2019, July the 26th, and I've received my MDT, or my minimalist double sideband transceiver from OzQRP. This is a kit that you can buy. It's purely just the radio, no battery, no microphone or anything like that. So I'll put links in the description below. I was going to first do an unboxing of the box that they send, and then again go through and build it and talk about bits and pieces that I found interesting as I built it as well. So this is the manual, the construction manual that you can find on their website, and this is the box itself. So within the box, this is what they sent me at least. A whole bunch of bubble wrap, and here you get the plastic case, and it looks like this. It opens up. These pieces of plastic will be, all the face plates won't be used. They'll end up, I don't know, maybe I'll do something else with them. The screws for this case are in this next part here. I've already opened up the box, so this is not new to me. A whole bunch of the bits and pieces are in here. And they also give you a letter saying, thanks for buying the kit, good stuff. Go to this website to get the information and download the manual so that you can build it properly. And if you have any questions, let me know at a certain email address. Very useful, very kind, and there's nothing else in the box. So that's pretty much unboxing and all done, except we want to see what's inside here. Again, I've already tried to go through and just checking the bits and pieces. Because in this instruction manual, he explains his reasoning for why he built the kit, how the kit works, get some box diagrams, and then you get some circuit diagrams. Most of these are beyond me, and then I've briefly gone through and checked some of the bits and pieces. It's all laid out, and then it goes into the construction itself, and that's what I'll be doing, and I'll be following this and letting you know if there's anything that pops out. I kind of recommend making sure at least you've got a copy that's in colour, especially when you get to the toroids. The toroids aren't labelled, but you can work out which toroids are being used here from the photos, but also from the description as well. And so that's what the construction will look like, and I'm looking forward to going through, and then you should do a check of how it's working at the end. Let's continue with the unboxing. We've got non-polarized capacitors, so a whole bunch of caps of many different types, and the construction kit talks about that. We've got the toroids of various different types, qualities at least. We've got some potentiometers and knobs, some more capacitors for the low pass filter, some electrocapacitors. We've got the back faceplate. These faceplates, my understanding is that they're actually PCB. That's the back, and we've got the front. So instead of these plates, I'll be using these to go on this. We've got the PCB itself in the back, and these are through hole plated. We get some wire, both plastic insulated, but also enamel insulated, so that we can put them on the toroids and wind our toroids. These semiconductors are inside a static proof or static resistant pouch to avoid breaking them. We've got diodes in there, the LED is in there as well, transistors and other semiconductors, and ICs are in there as well. screws for, I think these are, the big ones at least, are for the casing. They'll go into here. The smaller ones, I'm guessing, may attach to these sections here. Well, I'll get to find out later. Plugs and sockets, so we've got microphone and BNC and a relay, 3.5mm connector, DC, I believe that's 2.1mm DC connector, some pins for these headers and sockets. Whole bunch of the resistors, heaps of resistors, and I believe the trimmer resistors. And then in the parts list, this is described as a ceramic resonator, so it's not a crystal per se. Cool, and those are all the parts. So this is what you get in the kit. You'll notice that there's no battery, no antenna, you don't get any microphone, so you need to sort those kind of things out for yourself. But the kit itself is very well made, and as far as I can tell, all the bits and pieces are there. I wasn't able to go through all the resistors, but I didn't want to spend, I was spending a bit of time counting everything out. I didn't want to keep spending that time, and so what I'll be doing from now on is starting the build. And the notes say you should start with, not diodes, you should start with your PCB and then populate the resistors first. That's what they recommend. They don't say you have to do it this way, but they recommend go with your resistors first. And so that's what I'll be doing. And I'll follow along what the kit tells me to do, and then I'll let you guys know what I think as a rookie kit builder. Hey, I'm going to call it a night and keep working on this tomorrow. So far I've gotten through a whole bunch of resistors. All the resistors I've labelled here. So they don't really come in order in terms of, they're not ordered as in like R1 and then R2, R2's even with R5 and R30. And so I've just been doing in groups of values. One thing I'd possibly encourage is to, just what I've done is I've listed on the sides here which ones I've done, and then checked them for their continuity through the PCB as I've gone. And a recommendation I think for this instruction manual, it'd be really cool if another column could be made here with the resistor numbers, just like I'm doing here, and that would make it a bit easier, because instead what I'm doing is I'm having to go, okay, what value should I do? Okay, I'll do maybe 10 ohms, and then I have to go to here and go, okay, which one's the 10 ohm one? Oh, there's 4 of them, and then it's R13, blah, 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 and then I have to write R13, so on and so forth, and then I find R13 in that group, and then chuck them on the board. Small gripe. So this is the board as it's populated at the moment. I feel like I'm getting a bit more and more confident as I solder, and it's getting really easy to, as I go along, solder them in, and then I can quickly check and go, oh yeah, there's a ground is over here, and I can also, yeah, like with this resistor, there's like a point here that's going to be attached to ground, and I can see that it's attached to ground in here. So you can see that there's a ground plane underneath all this green stuff. And you see that this connection is grounded as well, and so you can easily check. While the board is this way, I go, oh yeah, there's a ground. I know that this is grounded as well because it's the power. You can see that this one's not grounded because it's clear all the way around, but this one is. And so it's like a quick. I know that When I'm checking to see if it's actually connected, that I've soldered it properly, I can quickly check for ground that way, and then also check other ways as well. That's nothing new probably to people who have done a bunch of soldering before. I'll come back tomorrow and keep on keeping on. Having a bit of fun so far. Good morning everyone. It's the 27th of July 2019. It's a Saturday. Time to finish off these resistors. Alright, so I've finally finished doing all the resistors and I've populated the board now. So all the resistors are go and I've checked them all, and everything seems to be pretty happy regarding continuity on the board. Next page is diodes and ICs. I'll get those done. I think there's not a whole bunch of them. Get those done pretty quick, and then I'll get on to the relays and non-polarized capacitors. Cool. Alright, I've gone through a whole bunch of the capacitors and trim pots. I went a bit further than I was planning to do, but I felt like I keep going, get most of it done. So I've done a bunch of all the capacitors. Some of them were a bit tricky. I had to try and identify them, especially C13 looked like an NPO. I'm pretty sure using a process of elimination I was able to figure out most of them, but there were a couple there. I'm pretty sure C13 was an NPO which had a number 101 on it. C41 has 221 label on it, meaning 220 picofarad. C14 said 471, which I'm pretty sure was the 470, and I'm very confident that C15 and 32 were labelled 102 and they're 1 nanofarad, but I'm not entirely sure. We'll see how we go. I'm pretty confident that those were the ones. The rest of the capacitors were very easy. These ones were easy to tell because there were just heaps of them. I haven't done any of the electrolytic capacitors yet. Trim capacitor done, resistors done, the vertical multi-turn trim pot and the horizontal trim pot were the last ones that I just did. So there's your vertical trim pot there, and then this is for the mic gain. That's the 5K horizontal trim pot. So those are relatively easy. I'm trying to think of anything else that stood out. I haven't been checking my capacitors as I've been going. Maybe that's something I should pick up as I go into the future. Diodes were easy thanks to the PCB and indicating which way they were supposed to go in, so it's fantastic. Otherwise, so I've been able to get through, got the relay in, so I got all those resistors in, diodes in, ICs are in, relays in, non-polarized capacitors are in, low pass filter capacitors are in. I actually did these ones first just to eliminate some to figure out some of these other ones. Trimmer capacitor in, easy, trim pots easy, and next steps transistors, and we'll see how we go. Sweet, so I've finished. I've just got the top case off. This is the lid for the top. And the lid actually has a certain way to go on. It doesn't, you can't just put it on any old way. It's all finished. I've got the mic set up. This I've got it screwed into the base. The potentiometers are working all good. Everything seems to be fine in terms of continuity. What else did I've done a whole bunch because it's just been 2 hours. What transformers are in. So this is the first time I've done winding of toroids before. This one was my first one. It's pretty janky, but we'll see how it goes. Then I did this one, then this one, then these three. And you get used to it. Toroids they're not too scary. What else did I put in? The electrolytic capacitors, I think. I can't remember what else. Connectors, pots, LED that you have to kind of bend in a little bit, and so it sticks out, and it should be blue. Phones, mic, yeah, so on and so forth. I don't know. I'm pretty tired. I haven't had dinner. It's about 8 o'clock, so I'm thinking of just getting going. And I don't know. It was a good build. I'm trying to think of in some parts. In general, it was really good, and the book was really good. Explained everything really well. I got no major issues. Thanks for coming along for the ride, and I'm looking forward to getting this on the air and getting tested. Got to get a power pack. Yeah. Alright. I need to sort out a microphone for it. So I bought this microphone, and it's a 4-pin plug that should fit into this 4-pin socket. The issue at the moment, though, I believe that this is wired incorrectly. In the MDT, the bottom 2 pins are push to talk. The number 3 here is the push to talk ground. This is how it's worked out for mine. And this is the activator. When the microphone gets triggered, it should be connecting these two here and making sure that the microphone is being picked up. So 1 and 4 is the mic, and also this one is the mic ground, and this is mic not ground for activator. How do I know this? I know this because I've checked that if I've got my my digital multimeter off to the side. I'll put it up here, and we can see in here this one's pin 4 for the mic, and this is pin 3, and you notice that they both go to ground. So those both are connected to each other because they're both going to ground. I can show that by showing this is ground at the back here, and so that's the top pin and this is the bottom pin, where the other 2 pins, so I'm on pin 2, is not grounded, and pin 1 is not grounded either. And so that's how the MDT is wired, or at least how mine is wired. So I need my handset to also be wired like this, but it currently isn't like that. Let me show you. So this handset has a 4-socket pin, and I've set this pin, you might not be able to see it, I'm not too sure. It's set up the same way that this is set up on here. So this is when the trigger is let go, and it is currently let go. I'll be holding it down using this rubber band later on. So it's currently off, and what I find is this. When I look at pins 3 and 2, if I put this in here, it's shorted. And the reason why it's shorted at the moment, the reason why this is shorted is because this is ground, and it's a common ground, where this, I believe, is usually RX or receive. I think, I'm not sure, I haven't opened this up, but I think there's a speaker in here. which could be used for CB radio, but I'm not using this for CB radio. I just want this to use as a mic and also as a push-to-talk trigger as well. That's all I want this for. So I'm not going to be using the RX pin. I find that there's no other shorts in here if I go through and check them all. This is shorted with the push-to-talk off. What I find when it's on, I find that the bottom two are not shorted. So this is no longer shorted, but it is shorted from 3, or it is now shorted 2 to 4. And so the way it's currently set up is that this is the push-to-talk. This is the ground. Also, I need to know where the microphone is, and I believe that the microphone is here. I believe the microphone is here. The reason why I believe the microphone is here is because of this. When I hook this up to 1 and 2, it doesn't sound like it's shorted. However, when it's set up to 1 and 2 and I switch this to AC voltage, I'm getting some fluctuation. Also, when I make a noise, the AC voltage fluctuates. And it doesn't do that for anything else. So this is with push to talk. See how it's not fluctuating very much? For that one, for 3 and 4. It doesn't fluctuate very much for 3 and 2. It may fluctuate for 1 and 4, but that's because 4 is currently grounded, and I believe 2 is ground. Now, I've kind of worked this out. I'm hoping that my theory is correct, my practice. I believe it to be true due to all the testing that I've done. So what I need to do is this. So this is what I need to do. Currently pin 2, whatever wire is attached to it, is the common ground, and I need to move that to both 4 and 3 so that it will match up with the MDT being a common ground with a mic and push to talk 4 and 3. So 2 will go over to here and to here at the same time. The mic at the moment is connected to the correct one. So mic at the moment on push to talk is at 1 and it can stay there. And the push to talk needs to be moved to 2. So 4 will go down to 2. Now 3 is currently RX, or receive, because it's shorted with the push to talk off. So whatever's connected to 3, I can just remove, and I don't need to use, because I'm not intending to use the microphone as a speaker. And then I'll be able to test it on the radio. I'll hook it up, and I'll finally be able to test its transmitting. I know it works on receive, so the receive's fine, but I need to be able to test that it's actually transmitting okay. So I need to make sure I've got a mic that does that. Cool. Hi. Just to continue, I've rewired the mic so that the earth, which is the black wire, is attached to 4 and 3. The mic is yellow. I found the wire was yellow, and I've made sure that's attached to 1. And red is push to talk, and I've attached that to 2. Green was RX, and that I insulated with some insulation tape, and it's not attached anymore. So I've set up the MDT, and I'm about to attach the battery. I know that the reception already works. I've got my headphones attached, and I'll have it warm up a little bit first before I attach the mic. I don't know if I'll be able to let you guys hear what's going on. There won't be much to hear anyway because this antenna isn't turned on. But what you'll see here is that it will go up to at least 0.04 amps or 40 milliamps, which is what is expected. I can hear it tune a little bit, but what I want to watch out for is when I'm plugging in this mic. I believe it works, and I know that one of the tricks of electronics is to try and prevent the smoke from getting out of the components, and hopefully when I plug this in it won't amp up the milliamps. So I'm going to disconnect the battery now, and that would have warmed up just a little bit. So you're following along with me, and I don't want to see this more than 0.04 milliamps again. Sorry, 0.04 amps again. Cool, so we've got 0.04 amps or 40 milliamps. And when I trigger this, I'm expecting it to transmit. I'm expecting the LED to light up, the blue LED at the front. And the amperage shouldn't go higher than 0.25 amps or 250 milliamps. So I'm going to give that a go now. 3, 2, 1. Okay, that's about correct. It went up to 0.13 amps, being 130 milliamps. That's actually what I'm expecting to happen. The sound went out, and I actually saw the blue light go on as well. And so it all looks like it's working correctly and looks good. I'm going to test it now. I've got a receiver in the other room, and I'm going to try and see if I can send from here using this antenna to the receiver next door. So I'm going to actually show that it's working. There seems to be a problem. Sorry, my MDT seems to have a problem. There's like there's a high-pitched tone, and I don't think that's supposed to be part of it. But I'll show you what it sounds like. I'll turn this is a receiver, and we'll see how you'll hear what it sounds like. It's currently on the lower sideband.
Testing. This is Zulu Lima 1, Sierra Hotel Papa. Testing. This is Zulu Lima 1, Sierra Hotel Papa.
Yeah, so that squeaky bit was me just fine tuning it, and it appears it's in the middle. I think it's like it might be the carrier or something. I'm not sure. Hello, happy people. Today's the 2nd of August 2019. And here's my MDT, and I finally aligned the transmitter. You would have noticed in that last segment, the last video, that when I transmitted, there was a tone that was accompanying my voice, especially as we scanned across the signal that I was sending out from this. Now that tone, I figured out, was the carrier wave, but we want to suppress the carrier wave. That's actually kind of the whole point of this radio, is that you have in a way two signals. You send out both a lower sideband and an upper sideband at the same time, and then you have the carrier wave that should be suppressed, but it wasn't being suppressed, and I was wondering why, and I was wondering how was I supposed to fix this. And of course, whenever you got a question, go to the manual first. So I went to the manual, had a look through, and went, well, I know that there's an alignment thing required. What kind of things could I do? Now, I don't have an oscilloscope, and I don't have an RF probe or a spectrum analyzer, but I do have another receiver, as you saw. And so I used that receiver to help tune out or suppress that carrier as much as I possibly could, using the trimmer capacitor 1 and the variable resistor 2. And that is here. So we've got the trimmer capacitor 1. You can see here it's labeled TC1. And the variable resistor is here. And there's a flathead screwdriver adjustment here. And inside the trimmer capacitor is it is Phillips, but I believe you can also use, well, I used a flathead as well. And you have to go backwards and forwards to reduce that carrier signal. So I sent out a transmitted and used the receiver and made it so that that tone essentially disappeared. I can't hear it anymore, and so now this is aligned and ready to go. And you just got to go backwards and forwards. I started with the variable resistor and tried to find a really good spot. You can use your LED a little bit. The LED will tell you if you're sending too much power, and if you turn it one way it'll get to a blue, and then you'll turn it the other way, the blue will go away, and then it'll eventually come back again. And so I recommend find about halfway in between, and then fiddle a little bit with the trimmer capacitor, and then fiddle a little bit with the variable resistor, and then go backwards and forwards, and you'll get to a point where you're just doing very fine movements to get rid of it, and you're doing very fine movements on both. Also keep in mind, for those who are not in the know, I had to use a metal screwdriver, which is not ideal, because when you touch the capacitor you change the capacitance. So I turned it a little bit, took the screwdriver away, and then listened, and then maybe turned it a little bit again, and the metal screwdriver does interfere a little bit with the variable resistor as well. So something to keep in mind. So now I've done the tuning for this thing, at least for the transmission portion. It's all ready to go. And then if you want to, you can just turn your mic gain up or down afterwards. So I'd adjust this variable resistor as the mic gain. You turn it this way to increase the mic gain, and then turn it anti-clockwise to reduce your mic. And you can actually turn the mic, if you need the mic to be off, if you're doing some transmitting and tuning out the carrier, then you want to probably turn off the mic, just so that any noises you make that could get picked up by the mic that you've got plugged in here doesn't interfere with your tuning or alignment. So it's all ready to go. I think otherwise, I'll get on to marking the VFO scale while I get to use it. I know somewhat of where bits and pieces are. I know that this is around about, for this radio, for me, it's around about, I don't know, I think it's 7.110 about, but it'll depend on your radio a little bit. At some point I will put in I'll increase my range and maybe put in a switch, but at this point in time I'm happy with how it is. Time to get it on the end, time to make some contacts when the weather is fine. Yeah, that's the build and alignment journey over. Thanks for following along.